Okay, the recording has started for our class here, and let me get my presentation. Okay, probably this is better. And display mode. Okay, first of all, did I share this presentation? Let me see if I have shared it with Teams. Share with Teams. Okay, we need to share with Teams. Now it's shared. Okay, so what we will discuss today is the neural networks with multiple output. Okay, and what we mean by multiple outputs is really, last time we looked at neural networks of only one output. Okay, so let me enable my pen here. Only one output here. Okay, but now we want to look at neural networks with multiple outputs. You can see here's one output, and here's one output, and here's one output. The question is, we need to answer two questions actually. Which one of those I consider as the output, the correct output, or the classification if I'm classifying? One. Two, how do I train such a network? Okay, inference and training, we need to answer these questions. If I look at inference and training, we need to use two functions here. Let's see if, okay, we need to use two functions. One is called Argmax and one is called softmax. And those two functions will work as follows. Argmax will come after the output. Notice this is the last step of the output. You can see here F0, the output of it 2.1, F1, the output 0.7, F2, the output minus 1.5. And then I apply this layer. In fact, you can think of it as an activation function. And Argmax has this property where it says, I'm going to assign a 1 to the node with the largest value, and the rest are zeros. That's the Argmax function. Very simple. So now if you're doing classification, you know that now that this is the correct output. You are classifying, let's say, for example, tree, tiger, and door. Okay, now you know that. However, Argmax has a problem when we derive it. It has a derivative of 0. Why are so concerned about derivative? Well, we need derivatives in training. So no good. Good for inference, bad for training. Time to think of another function. So now we use the softmax. And the softmax is beautiful function. Beautiful function. And here is what it does. What we will do, we apply these numbers to a softmax layer, which is this one here. Again, you can think of it as an activation function. And notice we get these, and notice that the outputs here, this is the output 0.785. And the second node, the output of it is 0.194. And the third output is 0.021. That's what's beautiful about it. Add them, 1. And that's why we call them probabilities. They are kind of probability distribution because their sum is 1. Okay, that's beautiful. And then what you will notice is that even if you have a very large number, let's say, for example, instead of 2.1, this was like 2,000. It will normalize it. All the answers will be between 0 and 1. Okay, that's the beautiful thing about softmax. No matter how many outputs you have, once you apply the output to a softmax, you will get outputs between 0 and 1, and the sum of them is equal to 1. Okay, all right. Notice the F's are the output of my original neural network, and notice that the S's are the output of my softmax. ولذلك هنيجي نقول طب how do you compute those softmax? Well, the softmax is computed via simple formula. تبعوا معي. هل الاوتبوت تبع الاوريجينال نيورال نتورك 2.1 0.7 minus 1.5. Here's what I will do. What I will do is that I will take every one of these numbers and raise it to the power, okay, of e. Watch. E to the f0 equals e to the power 2.1, which equals to 8.166, right? And then I have this one here. I take this output here and again raise it to the power e. And take this output here and raise it again to the power e. لاحظ I got three numbers. Now, to compute the S0, which is this one here, I divide what I computed for F0 over the total of these numbers. So I add them, I add this, it becomes a numerator for me, 10 point something. It comes in my numerator here. Denominator, I'm sorry. So S0 equals e to the power F0 over the sum of all the e's, which is 8.166 over 10.7. That comes to 0.785. Similarly, F1 here, I take e to the power F1, 2 point something, over the summation. Okay? And similarly, S2, right? So now you can see how we computed these output right here. Very simple math. Very simple. Just raise these e's, these outputs to the e to the power. Okay? All right? So that's the softmax function, right? Can we derive it? Yes, it has derivative. It has a derivative. It has a derivative. Okay, so what are the advantage of softmax? It preserve ranking. Yani the largest value will have the largest output of a softmax. Okay, softmax has a range of from 0 to 1. The sum equals to 1, right? And also it has a derivative. That is the key star here. That's why really we left Argmax, which gives me 0, 0, 0, 1, well, the largest. That's why we left it and we in training. So in summary, we use softmax in training and we use Argmax in inference and testing. لما بخلص التريننج and I deploy the machine, right, for classification, I use Argmax لأنها أسهل وأسرع, but bad for training because of the derivative problem. Okay, now softmax gives me a loss function, special for softmax. You see, if you stay without a softmax, you can use a loss function. تذكروا in the last class, how did we define the loss function? Well, we defined it with the medium or mean, I'm sorry, the mean of the square errors. Okay, the mean or the average of the square errors. Now we can think of a loss function in case of softmax. We can create a better loss function. It is called the cross-entropy loss function, and in fact, it performs better than the mean square errors. If you look at the plot here, you can see for small values of the s's, it drops very quickly to the ideal value. That translates to quicker training. Okay, so the mean square error doesn't mean it's bad and you will not train the machine with it. No. It is good for the machine, but it may take you slower time to reach. And when we say slower, that impacts machine which has hundreds of thousands of parameters or millions of parameters. So speeding the training is very beneficial, right? That becomes really critical. All right, so let's see. We'll look at how we will use this cross entropy. The cross entropy function, let's define it. It is if you have n output, Okay, so you have a machine with n output, right? And you use k training, right? Then the loss function is defined by this formula, which then we can simplify, and we'll see how we can simplify it by this what we refer to as the cross-entropy function, the loss function, 1 minus 1 over 1 over k, the len of our SKs. And we'll see what an SK, the SK, it represents the S function to the correct output. Okay, so let's see how we can simplify that. I'm gonna go for an example here, okay, and show you how we compute the loss function. Consider this example. Let's say we have 3 input patterns. We have I0, where the output is B, right? What B? Well, assume that I have 3 output, this output, this output, this output. Then I introduce the softmax layer for training purposes. And for the first pattern, B is correct. Okay, then the cross entropy function says that your loss is equal minus len S1. Why S1? Because it corresponds to the correct output. That's for the first input pattern. Let's go to the second input pattern, right? When we apply the second input pattern, we know that the correct output is C, right? This one here. So the loss is computed by taking the len of S2. Why S2? Because it corresponds to the correct output. Let's apply the third input, which is I2, right? What is the loss function? It is len minus len of, okay, the correct output is A, then I take S0. So minus len of the correct output, of the S that corresponds to the correct output. Now, if I want to take the 3 of them, I average them, right? And I apply the negative sign, لأنه len function for small values. What small? ما هو احنا قلنا كل الاس's بين 0 and 1 هيعطينا negative, right? So the negative of negative يعطي positive values. And this 3, because how many patterns I have? I have 3, so I'm taking the average of them. Okay, so really, if you look at how we compute per one pattern, in this case, I have one pattern here, and the correct output is 0, 1, 0, right? That's the correct output right here. Let's say, for example, I'm sending an image. I have a database of images for like door, tree, and tiger. Let's say, for example. And for this particular image that I'm sending, it should be tree. So the correct output is Y1. So I send the image, right? I compute the F's and I compute the S's, right? Now I want to compute the loss function. It will be what? Well, it will be the len of the E, which corresponds to the correct answer. Okay, all right. So now this is E equals 0, this is E equals 0, this is E equals 0. So that now, يعني باختصار, oops, there is, no, you don't want to do this. Don't divide by 3, fix your, so it will be minus len of this number, okay? Minus len of the S that belongs to the correct answer. Where is the S that belongs to the correct answer? So these are the S that belongs to the correct answer. Okay. Okay, so this is a very simplified form. So let's take a look at larger picture. If I have n outputs and k input pattern, then I have to do an averaging of all of them, much like we have done with the example. Okay, much like we have done in the example of this here. So this is, إذا بدي أختصرها هاي بقول this is عبارة عن minus 1 over k. الk هنا 3, okay, of the len for the S, the correct S, right? SI or SG, whatever correct value is. Okay, for that input pattern, I go for that input pattern. What's the correct output? take the S of that correct output, take the len of it, minus it, okay, and add it to the other values and take the average. This is what now? I'm computing what now? The loss function. The loss function. طب ليش أنا بدي loss function? Well, how do you determine delta L over delta P? مش delta L delta over delta P تحسب لي إيش؟ The required updates on the parameters. صح ولا لا؟ How do I update the parameter أو البيتزا اليوم مالحة؟ That's my loss function. أعطيتك إياها. Right? My loss function بقيس الطعم، بقيس طراوة البيتزا. That's my loss function. I'm telling you the specification of my loss function. So if I want to compute delta L over delta P, then I have to specify the loss function. And now I introduce the softmax for multiple outputs. And I told you it has quicker training convergence. But now we have to compute a loss function for the softmax. Then this is the loss function for the softmax. Okay, عارف اللينك كيف؟ Okay. All right, if I want to do a derivative, هذا شوي إن شوية derivatives أحيانا أحيانا I have to walk a خلينا نقول a tight over a tight rope between going too much into math and or going too much into using these algorithms for application, not understanding the underlying math. So we find sometimes in some cases it is important to just get a little bit of the math behind it. Okay, so now we can understand the rationale behind these functions. And now obviously in the training, right, in the training, you know that if I want to have a delta L over delta P, right, in this case I have to compute delta S over delta F, right? There is this part. Let's okay. Let's take this a little bit. Let's talk about the dependency here. Okay, and then from the dependency we'll work it backward. Okay, we know that loss function depends on the S values. And the S values depend on the F function values, right? And those are impacted by the parameters. كويس؟ Now, هات لي الآن أنا بدي I need delta L over delta P equals what? Delta L over delta S وحدة. بعدين delta S over delta F, right? بعدين delta F over delta P. Delta F over delta P. That's the chain rule يا جماعة الخير. ولا لا؟ If you are interested in neural networks and AI, this is how we do things. Okay, this is how we update things. So part of this equation, which is right here, delta S over delta F, right here, it's in the middle here. So how do we compute this? Okay, how do we compute it? By the way, we'll do a difficult or somewhat not a straightforward expression, and then we will simplify it. Okay, so now if you look at this S0 here, well, it's dependent on what? F0 alone? No, it's dependent on F0 and F1 and F. Why? Because you see, to compute S0, look at this denominator. It has all the F's, right? So every S of those is dependent on its corresponding F and all the F's. That's making life harder. صح ولا لا? Okay, so باختصار, so you have really to do delta S over delta S0 over delta F0 and delta S 0 over delta F1 and delta S0 over delta F2. All of them are related to S0. لأنه S0 depend on all of them. Okay. Now, luckily, softmax simplifies in these derivatives beautifully. If you work out the math of these things, the cancellation, the simplification is beautiful, right? And I urge you, for those of you who are interested, to look at the proofs, to look at them. And now we take the results and we apply them. Okay, so now, then we will look at the second part, which is the delta L over delta F, okay? So what concerns me here, okay, let's see here, the delta L over the delta F, because we will go through a simplification. Okay, let me see if we simplify this for ourselves. Okay. S. So let's say this one more time. The loss function depends on the S, and the S depends on the F, and the F depends on the P parameters. And what we said is that delta L over delta P equals delta L over delta S times delta S over delta F times delta F over delta P. Now, here is the good news. أنا أعطيتكم الإكسبريشن اللي فات كان عن هاي، صح؟ صح ولا لا؟ الجود news إنه we can combine those in a very simple expression. Very simple. Delta L over delta F luckily maps to, right, SI minus 1 if this corresponds to the correct output. لاحظ اختفت الاس في الديريفيتيف ولا لا؟ الاس بلعناها، صح؟ لانه somehow if you multiply the first term, this one, with the second term, things يعني you should look up the proof حقيقة. يعني I need two lectures to show the proof, and this is not the focus of my class, but things cancel each other beautifully. But now I can combine these two, and this is the magic of the softmax. And now delta L over delta F becomes SI minus 1 if this corresponds to the correct output, or SI if this is not the correct output. Very simple. Very simple. Okay? Very simple, straightforward. Now, so for example, take for example here, I have these input patterns. I have an input pattern I0. And I know for this input pattern I0 that B is the correct output. This is the correct output. Okay? Now, what do I need to do? I want to compute delta L over delta F0, delta L over delta F1, delta L over delta F2. Right? Now, what did I learn? It is for those, where is the correct output? It's right here. Okay, because it corresponds to B. صح ولا لا? It's right here. So what is now the delta L over delta F1? S, which is this one here, minus 1. طب والبقية just the S values. Again, why this is S minus 1 والباقي S's? Because it corresponds to the correct output. That's right. طيب خلينا ناخذ another input I1. Okay, let me see if I can change the color. For some reason in color, okay, let's take I1 here. I1, what's the output? C. So this is the C output here. which corresponds to S2. Now I want to compute all these delta L over delta F's. I know that the correct output is right here. So all of them, the delta L over delta F will be S, their correspond S's, but here it will be S2 minus 1 because it corresponds to the correct output. Okay. Finally, let's take I2 here. I2. So this I2 here, it says that the correct output is A, which means this is where the correct output here. So where the correct output, I take the S0 minus 1, will baggy the rest S1 and S2 because they don't correspond to the correct output. Very nice simplification, and this is the magic of softmax. Their derivatives so beautifully cancel all the complexities. Okay, now let's take a look at the example here. This is very important example. Showed up it and other numbers could change in assignments, in quizzes, in exams, and it's important for you to understand how these numbers are created. Okay, so or computed, I should say. Let's because in this example we summarize the entire let's say the entire lecture. Okay, so here is an example. Basically, in the following example, shows the value of the last layer, which means the F values, they are that right here. Okay. Of how many input patterns? 3. This is first input pattern, second, and third. Right? Beautiful. So far, so good. Okay. Now, these are the values for every the correct values for every input. So for example, for the very first input, what's the correct value? 0, 1, 0, which means y1 is the correct value and y0 and y2 are wrong. Let's say, for example, you're classifying images. Okay, as we said, dog, tree, tiger. And we show an image and should be for the tree. It's not for the dog. It's not for the tiger. It's not for the well, I forgot. For the door or the tiger. Okay, so you get the idea. So the correct value here is what is y1, and for the second pattern, what's the correct value? Y2, and for the third, y0. Now, what do I want you to compute? The soft the softmax activation layer. So here is the softmax. I need to compute it. How? Without any derivations. Without any derivations. Any idea? Any idea? Any idea? Yeah. Like this. We have the F values. We take the exponent to every F value. That's the denominator. Then for every particular S, I divide its e to the power F value over the sum of all the e to the F's. Okay, that gives me the S values. These are the softmax activation layer output. Okay, so we go back to our example. Okay, so now you can see here, okay, so you can see here 0.78 for S0, 0.19 for S1, and 0.02 for S2. Similarly, for the second pattern, 0.68, 0.11, 0.21, etc., etc., when I compute the S values. Now, we want to compute bunch of derivatives, بس باللي يهمني أنا عادة في الأخير هان delta L over delta F0, delta L over delta F1, and delta L over delta F2. right? I'm gonna give myself cheat sheet here, a cheat which is not available to you in an quiz or an exam, but I'm just displaying here for you for ease of computations. When the output is 1, then the derivative is s minus 1. When the output is 0, then it's the value s. Okay, so let's see here. Okay, I'm gonna try to erase here some of the stuff that I did here. مشكلة إن I hardly find an appropriate color here. Maybe الأزرق لا مستخدم. Probably الأسود. Probably. Let's see if we do well, I use it. Okay, let's see. Let's see. Very dark, and even that one is used. So, okay, let's go back to the yellow. Probably the safest. Okay, so here is my s's, and now I need to compute those derivatives, right? And here is the rule. Where is I equals 1? For the middle one, right? Then I take the corresponding one here, and I say uh, this s minus 1, that gives me this number here. 1 minus 1 minus 0.19 gives me what? Minus 0.81. Now, the rest of these s's, right, will go back as they are. Why? Because their output is 0. صح ولا لا? Okay, so now you can see here this s is 0.78, and this loss function, and here delta L over delta F, and here, whoops, and here 0.02. Okay? Does that make any sense to you? Okay. طيب الآن let's take another derivative for the second input here. The second input, we see that the output is for the third one. So what do? I take this here, this value s 0.21, and subtract it from minus 1. That gives me minus 0.79. and الباقي 0.68 and 0.11 بينزلوا زي ما هم. 0.68 and 0.11 for delta L over delta F. Okay? Now, third input, I have the output of the first one is the correct output, which means I'll have to take the first S and subtract it from 1. That gives me minus 0.95. والثانيات 0.91 and 0.04 بينزلوا زي ما هم. They drop as they are. So that enabled me to compute what? Delta L over delta Fi. Now I need to average them. So for these three inputs, I add and I average all these values. I add and average, add, average. So I get these numbers. Okay? Okay, now, I hope this is understood. Okay? So this is one point I want to show up here. Another point I want to show you, I'm sorry, to show here, which is when we go here and compute the loss. Okay, so we need to compute the loss by taking the len of the s at the corresponding output. Yani we take the len of the s that corresponds to the correct output. So now we go back here. Okay, so now we take the len of the corresponding output, the len of the s. Where is the s? In this case, watch here. I have the 0, 1, 0, and then the middle one is the output, the correct output. Take the len minus. How about 1.566? You go back to the input. Where is the correct output here? Let's change color here. Say if I use red, for example. So let's go back. For the first loss, how is the output here? 0, 1, 0. So I take the len of this number, minus. How about the second loss? I take here what's the expected output? 0, 0, 0. Then I take the len of this number, minus len of this number. How about the third loss? Okay. Well, the output is 1, 0, 0. So I take the len of this first number, okay, of the first S, applying the equation. Okay, and then you can always compute the averages based on the three inputs. So what did I do in this example? I gave you the values of these functions, right? And I asked you to compute, and I gave you the expected output, طبعا, الواي's, and I asked you to compute the S's. I asked you to compute the derivatives of the loss function with respect of the F's. And I ask you to compute the loss functions. طبعا those are intermediate values. I'll leave them computing to you do yourself. It is correspond to this equation right here. Okay, you have to follow up the equation. Okay, very systematic in the computation. ما فيش فيهم إيش صعب. Is this clear? Okay. Is this anything not clear about this example? Okay. So basically, what was presented to you in this class, let's go back to the original problem and what we are trying to address. We are addressing the inference and training of network of multiple outputs. We say that the network of multiple outputs, the outputs, the output can vary with the wide range. Okay, so we need to decide on which is the winning output. So we use the Argmax, which basically assigns a value of 1 for the output which has the highest value, zeros for the others. Very simple, very easy, but it has a problem. What's the problem? The derivative of it is 0. So we move to say, okay, we'll leave argmax and the inference. Let's use another function, which is the argmax for the training. Okay, and we say that the argmax has beautiful features such that it when you add the output of the the softmax, when you add the output of all the nodes of or the output nodes from the softmax activation function, they will add up to 1, and all the outputs are between 0 and 1. And that's why we call them probabilities or predicted output or predicted probability. Okay, they match to probabilities very nicely. And then we looked at how we derive the derivatives with the respect between the loss function with respect to the function, because this is required for during the training. Okay, you can buy okay, which is the mean square errors, without going through all this hassle. But this seems to be a much better approach for training and evaluating multi-output neural network. Okay, any questions? Okay. So the question is, why do we need to learn the computation of the neural network in our class? Well, first of all, these are neural networks. You are expected to understand how they work. Now, no one is asking you to design a neural network and do the computation by hand. In fact, none is done by hand. At the end, you program the neural network in a programming language of your choice, Java, Python, whatever you want. Obviously, the language of choice is Python. Now, then the question, why do I need to bother with these things while I have already made packages that people can provide me? They are already trained. And the answer is those packages, they don't teach you neural network. Those packages are good to apply neural network. In this class, we teach you to understand what's a neural network and how it works, right? Exactly, if I give a car or a motor vehicle to someone who wants to drive it, and I coach this person to drive the car, that will be the average person. But if you are a mechanical engineer, you must understand how this car, right, works internally, whether it has electrical engine or combustion engine or a hybrid engine. I don't expect the average person to know these details, but I expect you as a computer engineer or computer science student to understand the details, because this is your major. So when people talk about transformers, for example, and they have inside them neural networks, you can appreciate these details and you can appreciate the complexity. But I don't expect, so for example, a doctor who all what he does or she does, they have bank of images, they feed it to a neural network from somewhere, and they can train it very quickly. But they don't know what's going on. They don't know how this works. You are expected to know how it works. Okay? All right? That's the whole difference. You understand the algorithms, the theory, the basics of how these being treated. Very easy for me to convert this class to be application. All what I need to do is say, point to this library, download these images, and train them. How much understanding you got? I don't know if there is any, حقيقة. Exactly like the driver of the car and the mechanics who understand every wire in the car. You are in computer engineering here, or computer science, by the way. You're expected to know that level of details. Okay? Any questions? Any questions before I turn off the? A good question, by the way. I mean, that was very um, good, let's say, indication of why we go to that level of details. Let me turn off my recording. By